Okay, so what I decided to do was, I taught you about motion planning, but instead of having homeworks, I just decided I'm going to make a project. So you could, well, so here the problem is there is this robot called Pioneer 3DX. It's actually a popular robot which you can buy. You could buy, I don't know if you can still buy it, but it's been used for education, robotics education. You need to get this robot to go from start to goal, the black dot. And then there are these obstacles. All obstacles are red in color, okay? So what I want you to do is, so okay, how will you do it and what you need to do? Well, you need to clearly go to the goal, but how will you do it? Well, it turns out that this robot has got sensors on it. There are actually 16 sensors, and they're all ultrasonic sensors. You use ultrasonic sensors for the wall following robot. These sensors measure the distance. So there are 8 in front, 8 in the back. This is the forward direction, so you can start counting from the way I've shown here. This blue dot indicates the XY position of the robot, and then the theta is the angle made with the x-axis. Okay, so that is something which I've done the work for you. Now here's what the sensors do. Any sensor at any point of time provides you with some information of the obstacle. Now this is one obstacle, and all that the sensor can provide you is this particular value, D observed. Okay. So it's going to be the point closest to it. So what I did was I took this D observed and I converted it into X and Y observed. So this is basically global information of the obstacle. It's not telling you, unlike what we did with in the Python example, I gave you circular objects, and those circular objects are defined by a radius and a center, right? So you pretty much know the entirety of the obstacle. But here with the proximity sensor, you can only get what you see. So what the robot sees is only this point. And so I converted this point using this D observed. I actually assumed it to be a straight line jutting from here, and then I used that to convert that to a global position. It sort of is a crude approximation of xi, yi observed, but it will actually work. At least I got it to work. So it'll give you both these pieces of information, and what you do with this information is up to you, right? So you have access to 16 sensors, and you have access to x, y, theta, and then I did this work of figuring out what this global position is, x observed, y observed, and d observed is. And your goal is to use this, let's see, 1, 2, 3, 4, 5, 6, 6. Well, this is 3 times 16, right? 48 pieces of information to figure out what you're going to do. Now, if there's no obstacle in the path, then it actually gives you infinity. So you can ignore that value. There's no obstacle. So you're going to use these sensors, or this pieces of 48 plus 3, 51 pieces of information to make the robot avoid the obstacles and go to a goal. And then I think what I did was, let me zoom out. So there are 4 planners I talked in the class. There's a go to goal and obstacle avoidance. There's potential fields, dynamic window approach, and model predictive control. So if you're an undergrad, you signed up for 3 credits, you just pick 2 out of 4. You don't need to do all of them. I mean, you just do 2. Okay, whichever you find easy, just do it. Use 2. And if you're a grad student, you sign up for 4 credits, you need to do 3 of the 4. And you can choose whichever you want. The way this is going to be is okay, so what will happen is that there are like 4 scripts. You can sort of see it here. I was hoping to show it in Copilot Sim, but you can see there are 4 scripts. These scripts are for the 4 planners. So what you need to do is don't run all the scripts together, right? You want to run one script at a time. So what you can do is to set the script, click on this icon. So first select the script. Let's say you want to enable or disable this one. Click on the magnifying lens. That's number 2. Number 3 is you can enable, disable it. So once you enable it, you will see that it doesn't have this stop sort of sign, the red color mark, right? That means it's going to run. If you want to test out potential field, you'll disable this script and enable this one. Do the same thing. Click on this, go to magnifying lens to enable. Okay. So once you do that, you'll be able to select a particular script and then use it. Now, there are some suggestions I have for you, which you can read about. You probably don't want to use 16 sensors, right? You want to use a subset of them. You also have information to X, Y, and D. You don't want to use all of the pieces. You can, the way I did it in the class was I just used the global information. So I use X observed and Y observed. You might want to use that instead of trying to use D. Uh, and then the way I've done in the class also, you've seen, first what I'll do is I'll first tune the controller so that it goes to the goal while there are no obstacles. That's the first thing you want to do. And then what you want to do is you want to add obstacles and then see if it can. So the grading is going to be the following. Uh, you are going to try 2 planners. First, you finish the course I gave you, which is this course, right? And then I do the same thing I do for the maze following, which is I'm going to move. There are 3 things I could move. I could move the Pioneer 3DX, I could move the goal, or I could move the obstacles. So when I move it, I'll maybe move 2 or 3 things, and then we'll see if it runs or not runs. And then you can, it's exactly like the maze following. You'll just, it'll be a different code. It'll be this particular project, which involves the motion planning. Okay, so that's the plan. And so you will do this for, given the grading, it's basically 100 points like before, same for grad student, and that's about it. Okay, so what anything I give you in the class, I basically solve it myself. So I have solutions to all the homeworks, and of course for this, I was able to get it to work. I essentially took the code which I wrote down which I provided you, the Python code, and just modified a little bit for this one, and it worked. So you just need some tuning here and there. The parameters will not work because it's a different problem, but you need to tune it. And I think it's fairly straightforward. So this is how I would say an actual robotics problem is. Well, we don't have hardware here, but that's how it will be. There will be a system, and there's fair amount of tuning required based on what it is, just like your maze following. So hopefully it will be a good experience for you guys.